All right, so let's go ahead and continue on with differential equations and with a dy dx type thing, or using all the stuff we know about equations and derivatives and all that stuff. So this time we're going to be dealing with our velocity and acceleration and all that great stuff. So example 4 here, and there's only 6 examples, so we're almost done, guys. We're almost done. The acceleration of a body moving along a coordinate line can be modeled by the function a of t equals cosine t. Find the velocity and position function if v of 0 equals -1 and s of 0 equals 1. Now, one of the things about this that it was done earlier this semester, we talk about the different types of equations. Let me do it on the back here. Talk about equations. We know first off that our position equation is the original equation. That's the original equation. When it comes to our velocity, that's our first derivative. Equation. Right? And then acceleration is our second derivative equation. So whatever our second derivative was, that's considered acceleration. Whatever value you get, answer you get with that, that's your acceleration. That's how fast it's going. Not how fast it's speeding up or going down. Now, yeah. So for velocity is one of the things of where it's like your first derivative. That's the speed, like how fast it's going. Acceleration, it makes it go faster or makes it go slower. Velocity is your speed that's going. And your position is what you originally have. So here, they gave you the acceleration. Sorry about that. They gave you the acceleration. And this is example 4, sorry. They gave you acceleration, which is a of t, equals cosine of t. And they say, okay, now find velocity, the velocity equation, and the position equation or function. And position. That's the and symbol. And they call it function on this problem. So here, we're going to find the velocity and the position. So that means we need to go from second derivative back to first derivative, and then go from first derivative back to the beginning, the first equation, the original equation. So that means here we're going to be doing this kind of twice. Not kind of twice, but we're going to do it twice. So with it, again, hopefully you guys remember your antiderivatives. So here, I'm going to rewrite this a little bit. So our velocity is going to be your integral of acceleration, dt. So velocity is the antiderivative of acceleration. So here, acceleration is cosine t. So the antiderivative of cosine, and hopefully you guys remember, especially if you're taking this AP test, you have to know these values. You need to know these tricks because they won't give it to you. You have to know it. So that sine is the antiderivative of cosine. All right. So now we have our velocity equation, our general equation, but then they gave us the actual initial value, and they said v of 0 equals -1. So v of 0 equals -1. So our velocity, so that means that's t, that means that's our velocity. And remember, that's pretty much y. So here, that would be -1 for this portion. Then that's sine of 0 plus c. All right, so again, you have to know your trig values and everything. So again, here, this is 0 plus c, -1. All right, and then c is actually -1. So for this, our general ones here, I'm going to say GS for general solution, and our particular solution for this one is here. So we have our velocity one. So we've dealt with velocity. Now they say, okay, now that we found velocity, use that to help us find your position. So just like acceleration, the velocity was the integration of acceleration. So position is the integration of velocity. And we just found out what the velocity was. We're going to use the particular equation. That's the sine t minus 1 dt. So again, we're talking about derivative. All right, so we're going backwards. So we're doing the integral of sine, then we do the integral of -1. So integral of sine is negative cosine t, and then derivative of integral of 1 is negative t. Well, integral of -1 is negative t, then plus c. And then again, they give you your actual initial value. So s of 0, they said equals 1. And so separating these off. So here, that's going to be your t again. That's going to be that's t. This is your y. And so we substitute everything in. So it's 1 negative cosine of 0 minus 0 plus c. All right. So again, with this one, you need to know your trig values. And so here again, this is -1. Because cosine of 0 is 1, there's a negative in front. That's 0 and c. So that means here we have c equals, if we add 1 to both sides, c equals 2. So our particular solution is negative cosine t minus t plus 2. And so those are our particular solutions. And that's what they were asking for here. Find those functions. So again, not hard. It's very simple, very easy. It's just got to do the work and know your trig values.